conducted a test. Yahoo conducted a test, right? To check the speed of various databases by taking a table, has taken a table, right?
So it supports
And
parallel processing, right?
which one? Yes,
It's up, yeah.
very high speed processing because of parallel processing. So parallel
Uh,
processing, right?
what, sir? What is the meaning of commodity hardware?
Commodity hardware means Hadoop can run on any hardware configuration, right? It doesn't mean that very high configuration required, not like any systems, right? And it doesn't mean that all the systems need to have same configuration. No, it can run on any system, any configuration, right? Yes. And
Oh,
okay, it is an open source, no licensing required. Most of the products we take Hadoop products, right, from Apache side, and can handle all varieties of data, structured, unstructured, and semi-structured kind of data. Very high speed processing because of parallel processing, unlimited data storage because of there is a feature called horizontally unlimited scalability that I'll be discussing in brief, right, in the tomorrow session. But I'll be just briefing you about all these advantages, right? So tomorrow also you'll be attending just to attend the session to see more on this, right? So tomorrow I'll be just briefing you about these advantages. Why only Hadoop can go with unlimited data storage? Why not databases? Why only, and why Hadoop has got very high speed processing? Okay. So I was giving an example that Yahoo has taken a table of 100 TB consisting of 1024 columns. The task was sorting based on 16 columns, right? So what is the time taken by different databases? Time taken, right? Different databases. So here Oracle has taken nearly 3.5 days, right, to process this, and MySQL, MySQL, right, it has taken nearly 6 days to process this. 6 days, right? Yes. But we have got some specialized databases like Teradata, which can handle huge data, right? Like TBs of data. It has just taken 4.5 hours to process that. And when more specialized databases like Netija, it has just taken like 3 hours to process it. And finally, Hadoop has just taken 3.4 minutes, right? 3.4 minutes to process it. But latest version of Hadoop, just 1.2 minutes, right? Yes, 1.2 minutes. So this is what the speed of Hadoop, right, as compared with the other things. But Spark has got very high speed rather than Hadoop, right? Spark has got very high speed processing because of in-memory computation, memory level storage, and memory level processing you are going to see. Yes. So this is what Hadoop proven in the market, storage point of view and processing point of view, right? Processing point of view, very high speed. Storage point of view, unlimited data storage. Okay. So what I'm going to discuss as part of this course, right? My more concentration will be on Spark and Scala, right? So in Hadoop, some important components I'll be discussing more. And there are some components which are outdated. I'll be just giving you knowledge on those, right? So here, so introduction to big data, challenges in big data, comparison with other technologies, HDFS, Hadoop distributed file system, right? And MapReduce. For processing. So it is Hadoop development training, right? Yes. Most of that will be concentrating on Hadoop development, right? Hadoop administration also will be discussed. but most concentrations here will be on development side. So here MapReduce meant for processing is a parallel execution model, right? And Scoop for import and export operation for pulling the data from databases, right, to Hadoop, again from exporting data from Hadoop to databases. Scoop import operations, right? Scoop import SQL plus Hadoop. Yarn, yet another resource negotiator, right? So there were some architectural changes, right? And there were some previously some problems within this Hadoop 0 and 1 versions. Everything got rectified from 2. So we call it as yet another resource negotiator. So in Yarn architectural components, yes, please be in mute. Yarn architecture and Yarn components, Yarn how the processing is going to happen. Pig, it's one more processing component, right? It's a data flow language. We use like pig scripting. So, and also next is I am discussing Hive component, right? Hive is an important component of Hadoop, right? Which is used in every project. Like it's a kind of data warehouse kind of environment in Hadoop framework, where we'll be creating tables and perform querying, right? We'll create different types of tables, internal, external, partition, non-partition tables, right? And here we'll be loading data, we'll be creating tables, working with XML data, working with JSON data, URL and weblog data for unions, joins, like inserts, inserting into local files, UDF, user-defined function, user-defined aggregated function, user-defined tabular functions, non-partition tables, static partitioning, dynamic partitioning, right? Multi-column partitioning, bucketing in Hive, indexing in Hive, right? Combination with bucketing, indexing, index and bucketing, partitioning and bucketing, partitioning, indexing, partitioning, bucketing, indexing as a combined, right? Performance tuning mechanism, right? And NoSQL database. At least you need to have knowledge on at least one NoSQL database. So what are the different NoSQL databases? What are the differences between them? And we are going to discuss one NoSQL database like HBase. And coming to this Spark Scala, right? Before the Spark, I also discussed like streaming data and technologies like Flume, Kafka, right? And
Sorry,
also like
above Spark and Scala is the admin part or configuration part. What exactly it is divided actually? Like in the normal application based upon Java or .NET or C Sharp, whatever you call whichever technology, or maybe Python, whatever. Or so our front end is UI, any UI, Angular or whatever you are using. Then the business logic is written in C Sharp, Java, or whichever language you want, right? Then it is connected bind with the database, right? And for database we can developers uses normally PL SQL and all that stuff. So how exactly it is used? So how it is divided? Is this the configuration part or the admin part, or how what exactly
yes,
the above part is? Actually, that is what my ask is
so
about.
Akshit, right? Akshit. So
Yeah, yeah.
here, one thing, there are two types of applications, online applications and batch applications. Whatever you discussed are for online applications. Online applications, that is what client server architecture you follow there. Client server means request response architecture you follow, like whatever you see in Java, .NET, Python, like MVC architecture, MBT architecture, right? MVC in Java, MBT in Python, right? So those are for online applications like request response architecture, right? Client server architecture. Those things we are not going to follow here, right? In this big data Hadoop or Spark, right? We follow master slave architecture. Tomorrow I'll be briefing you about that basic architecture of Hadoop, right? Master, single master, multiple slaves. It's not like request response. You're giving a request, getting a response. Hadoop is not for online applications. Hadoop or Spark, right? They're for batch applications. Batch applications means user, you see, user interactive applications. That's online applications. User interactive applications means user gives the input. You are booking a movie ticket or railway ticketing, or you are making online transactions. All those are online applications. User involvement required, compulsory. But what all we discuss is user non-involvement. What are batch applications means? User non-interactive applications. User non-interactive applications, we call them as batch applications, where user is no way involved here, right? Means all our background applications which runs in the background. Most of the financial applications are background applications. For example, background application, simple example. For example, generating credit card bills for millions of customers. User nowhere required. User is not going to give any input here. Phone bill generations means statement generation, right, for millions and trillions of customers, right? So here where user involvement nowhere required. So these are batch applications. So Hadoop is meant for batch applications, not for online applications, right?
So it will also convert the raw data into structured data. That is
Yes. What you can do is
like
ETL. You can
in earlier in we
like
use Informatica and all that tool,
yes,
right? So
exactly. And what I'm talking, that is ETL. You can do it here. You can extract, you can transform, and you can load, right? You can just pull the data from different data sources, from databases, OLTPs, right? You can pull the data by using scoop component here. Scoop is the component which works only for databases and Hadoop only, no other component, right? Scoop, SQOOP means first two characters from SQL it has taken, last three characters from Hadoop AI has taken, formed scoop. SQOOP, last three characters of Hadoop, first two characters of SQL. So it is for import
So
and
which
export operations.
distribution you will teach? Hello?
Yes.
Yeah, which distribution you will teach? Hadoop, that is a map, that is MapReduce and Hadoop. Is there a Cloudera or Horton? Which one you will teach?
Cloudera.
Cloudera. Manager you will teach, or individual things installation you will teach?
See, individual installation.
Okay.
So here, okay, that's what I'll also show you like how to install all those and how to configure those components, right? And how to download and how to configure one by one component, right? If you install Hadoop only with see two components like MapReduce and HDFS only, but all the other components separately we need to configure. Means not in Cloudera. If you are using separately, if you want to know the installation process. Okay. So yes, that is what Hadoop is meant for: batch applications, millions and trillions of records if you are pulling from different databases, right? And next you are going to process with some business logic, right? After processing, right, you can storing and again taking the data back to databases, right? For that data ingestion tools available, right? Like we go for Scoop is one, Flume Kafka we can use, right, for streaming data. Pulling some streaming data and just storing in this HDFS.
Like we have got right now, clouds are there, right? Amazon Web Service or Azure. The Azure Data Factory is being used, right? So the same concept is here in this Hadoop also. I mean, what is Cloudera actually? So someone asks, now so I don't have. Maybe that person is an experienced person.
So no, not like that. Cloud, it's not. We are not going to learn anything like it with Cloudera. The only thing is it's a kind of where you are going to run all those things, right? Environment. So it's a kind of distribution where you are going to see all the Hadoop related components pre-installed in that, right? It's a kind of environment where we are going to run and execute all the things, right? So here one thing
is nothing to do with any cloud, right? Amazon Web Service
yes,
or
see one second. So forget about it, right? So it's a kind of, don't think a Cloudera means totally like cloud related everything, right? It's a kind of distribution where we are going to see all the Hadoop components pre-installed in it. So otherwise we are going, I'm just going, for example, for it's nearly like 30-35 GB you are going to download it. But instead of that, right, people with low count means people with you require high RAMs for it. But I'm going to provide whatever I have created a separate, means where you can see all the Hadoop components. I'm going to provide you with a VM image, right? Virtual VMware. So where you can work with all the Hadoop components and Spark components, even like Hadoop Spark with Scala, PySpark, all those components. Just I'm going to provide you where you can just download only 6 to 7 GB. It's enough, right? Because so not a worry, right? So everything will be discussing in brief. So we'll be spending more time on this course, right? Nearly we'll be spending 75 hours on this course. So in that 75 to 75 hours, right? Mostly my 45 hours I'll be spending on Spark and Scala, right? So here totally we'll be discussing about this. Spark is meant for processing. How do both it can perform storage and processing, right? Means for huge data storage and processing. Okay. Yeah. Any more queries you have got?
So, for practical purpose, for our own homework assignment, like, so where we will get the data? I mean, there would be a huge data for processing if we want to do the practice, right? So, I mean, how can we do it? Because normally we can install standalone Oracle if you want to go, or if you want to run any SQL queries, or if you want to create table and whatever user we can create it, right? So how can we do it in our personal laptop and in Hadoop or that is.
Yes. I'll provide you where you can get from that data, where you can get the data sets, and I will be providing data. I'll be forwarding to your Google Drives, right? I'll software related and data related, data sets related, everything I'll be forwarding to your Google Drives. And about software, not a worry, right? Even if you've got whatever system it is, right? I'm going to provide you multiple. If you've got a high configured or low configured, not a problem. Hadoop, I'll make you install in your systems, right? Hadoop and Spark both. So as part of the course, we'll be discussing Hadoop and Spark with Scala, right? First, I'll be discussing about Scala programming before I go with Spark's Scala. Scala control structures, Scala collections, transformations, Scala functions, all after discussing about Scala. I'll come to this Spark core programming, introduction to Spark, how comparison with different technologies, Spark data objects, RTD, computation, persistence options, Spark core computation, fault tolerance models, different ways of creating groupings and aggregations, right? Various inbuilt actions and transformations one by one with many working examples. And next, Spark SQL, making data structured and working with different data frames here, making data structured and working with the data frames concept here. We have got many data frame APIs available and working with different file formats also, CSV, JSON, integration with MySQL, integration with Hive, right? And many other things, right? Hive and HBase integration and deployment modes, local mode, cluster mode, right? Within the Yarn cluster, standalone cluster, Spark applications, stages and tasks, derivatives and executors, and Spark submission, how we submit Spark jobs. So submitting and how to create jobs using IDs, like how to run on this Eclipse ID, how to run on IntelliJ ID, and using build tools like SBT build tool and Maven build tool, right? And also knowledge on Spark and Cassandra, right? Yes. So the timing of this batch, once again, I'm saying, right? So the timing of this batch, so for the demos are for 1 week like this, 1 week, 10 days, it will be at 5 p.m. But the timing of this batch will be at 6 o'clock. 6 p.m., right? Yes. 6 to 7. Daily, it will be at 6 to 7. But first 1 week, 10 days, it will be at 5 o'clock, right? Yes. Yeah. So tomorrow also you can attend the session to see more on this, right? I'll be just briefing you about the other things of how exactly the data storage and why only Hadoop can perform, why not the other things, right? Yes. Yeah, it will be from 6 to 7. From first 1 week, 10 days, it will be at 5 o'clock. Later, it will be at 6. Before itself, it is said, right? Yes, I'm saying here itself. Okay, fine. Any other queries, right? Anyone? So about the software, other
Sir, one
things.
doubt.
Yes.
Sir, one doubt. Sir, is it better to learn Spark with Scala or Spark with Python, sir? Which one will be helpful for big data?
So yes, by default, Spark built by using Scala language. By
Okay.
default, Spark is built by using Scala. Everything Spark is designed with Scala language, right? But today, previously, only Scala was much used now. Even now, also both Scala, that is what Scala and Python both are used. But Python, like if you are going for helpful for machine learning kinds of applications, those things very much used, right? But now, but as per Spark is concerned, Spark APIs or Spark related everything will be same in the same using Python or using Scala. Only the programming is going to change. It's a Scala is one programming, Python is one programming language, but the core Spark execution, the execution model, everything remains same. The inbuilt transformations, actions, everything whatever we see in both remains same. The only thing is kind of programming is differ. It's going to differ, right? Yes. So even I take PySpark classes in the weekends, Saturday, Sundays. We have got PySpark batches running, right? So, but
Okay.
if both are used, right? But the only thing is Spark. You need to know how the Spark execution implementing on
Okay.
which language, multiple language, multi-language support. Spark can be you can code it by using not only Python, Scala, using Java and R language also you can code it. But Spark execution remains same in all this, right? Yes. Okay, fine.
If you have both Scala and Python, it will be helpful, sir, in real time in the future.
Yes, yes. If you have got time to update, right? Even you can do that. Spark with Scala implementation and Python implementation, right?
Okay.
So
In Python, do we require advanced Python also, sir? Core and advanced both?
no, not required. General basic Python and it required, right? Yes.
Okay. Okay, sir. Thank you.
Okay.
Hello,
So yes, yes.
sir. Actually, I'm working, so I won't be able to attend class all the days. So I will go through the recordings. So I will
Yes.
try to attend once in a week. But if I'm getting any doubt and I'm getting stuck somewhere, so how can I connect with you?
Yes. So in such case, any day you can attend. Otherwise, if you have got multiple doubts or many doubts, right, you can ask me for a time, right? I want some time if you want to clarify your doubts. A
Okay.
WhatsApp group will be there, right? For once all the students got enrolled, for the students to interact, right? So in that you
Okay.
can just ping me, right? So if you want any time in special, otherwise during the class, if one or two doubts, you can ask any one day. You can attend at the start or at the end of the session. You can ask, or if multiple doubts or if anything, you can just ping me, right? To ask for some time, right? I'll provide some time and you can clarify those, right? Yes.
Okay. Okay, sir. Thank you.
So recordings will be provided. Yes, every session is a video recorded one. You will be getting the session recording daily basis. And clear notes also will be provided. What all the practicals we do, I'll just forward, right? In a soft copy of those. Fine. Yeah. Tomorrow also you can attend the session to see more on this, right? With the same link, same time, right? Yes. So if I'm done with your queries, I'll just sign off for now. Meet you tomorrow, same time, using the same link, right? Thank you all for your time. Thank you. Yes. Yeah, in the yesterday session, just I was discussing about what is big data, why Hadoop drawbacks with current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yeah. Currently, we have got a databases, right, for OLTP, online transactional processing, and we have got specialized databases like Teradata, Netezza, Vertica for data warehouse purposes, which are used for analytical processing, right? Yes. But either databases or specialized databases cannot support unlimited or huge data, right? So as a solution that for all the storage level and processing level problems, right, we have got a framework called Hadoop. So generally Hadoop is meant for two things. Hadoop is meant for first storage. Yes. Hadoop is meant for processing. It is meant for storage and processing. For storage, Hadoop doesn't use any database, right? Because databases has got some drawbacks as I was briefing about. Yes, storage. So it is going with a special kind of file system called Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce. Or we go for Hadoop, or what is that, Spark, right? Yes. So processing, MapReduce or Spark. For storage, HDFS, right? Hadoop distributed file system. So Hadoop can perform both storage and processing. Any technology performs either storage or processing, but Hadoop performs both storage and processing. You may ask why databases can't be used? Why databases can't be used for storing Hadoop data? Drawback with current databases. And before that, as I was saying, that Hadoop is meant for batch application. See, one thing what you need to understand, Hadoop is not for online applications. Hadoop is not for request response. Hadoop is not for client server. Hadoop is for batch applications. Batch applications means millions and trillions of records, right? Processing millions and trillions of storing and processing, right? Batch. Hadoop is for batch applications. For one record or one transaction, right? Hadoop is not required. If you observe, right, there are two types of applications. Two types of applications, right? Yes. One is online application and batch application. Batch application. Online application, user interactive. What do you mean by online user interactive application? User interactive application. Here user gives the input, right? Yes. Here user gives the input. Yes. Here the user gives the input. Example of online application, right? Yes. Booking a movie ticket. Yes. Booking a movie ticket. Making a online transaction, right? Yes. Making a online transaction, right? Yes. Yes. Batch application. Batch application. User non-interactive application. User non-interactive application, right? Yes. User non-interactive applications. Here, user is nowhere required. Here, user is nowhere required. Example of batch application. Credit card statement. For millions of customers, right? For millions of customers. Credit card statement generation for millions of customers. Yes. Mobile statement, mobile statement generation. For millions of customers, right? Yes. For example, if I give an example for batch application, for example, if you are booking a railway ticket, right? Your waiting status, PNR status is 200. After 1 hour, it is 170. By today night, it is 120. Tomorrow morning, it is 70. Tomorrow evening, you got confirmed, right? Means it is here user not giving any input here. It is a background application which runs in the background, right? Okay. Most of the financial applications are batch applications. Most of the financial applications are batch. Yes, 1 second. Yes, observe here. Online and batch application. Hadoop is for only batch applications, right? Yes. And if you talk about why databases are not used for storing Hadoop's data, what are the drawbacks? Means limited storage we see in databases. Most of the databases, no parallel processing. If volume increases, speed decreases, right? If and I just given with an example, right? I've just showed with an example. If you observe query to query, if you observe this query 1, 2, and 3, yeah, I want sessions to be interactive, right? Yes. Try to respond which query executes faster among these 3. Yes. Total amount from sales 1, sales 2, sales 3. Sales 1 has got 10 records, sales 2 has got 1 lakh, sales 3 has got 1 crore. Total amount of 10 records, right? Yes. Total amount of 10 records, right? This query executes faster as compared with the other ones, right? Yes. Yes. So query to query, as volume increasing, speed decreasing, right? Complexity increasing, speed decreasing. Observe here. To sum of amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1, right? So average, see, if you see which query executes faster means again the first query, right? Because average amount is a 2-step process. First sum to be calculated, next average to be calculated, right? Yes. Standard deviation of amount, right? So a lot of internal processing required. So as compared with this first and second query, third query is going to take more time. And a major drawback with databases, they can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? So before I go with Hadoop advantages, just I'll brief you, right? Hadoop, what do you mean by Hadoop cluster? Group of CPUs. Group of CPUs means nodes, we say. Group of CPUs, nodes connected in a network. Connected in a network, right? Yes. Group of CPU nodes connected in a network. There are two types of nodes. There are two types of nodes. Master node and slave node. Master node and slave node. In Hadoop, data stored by the slaves and data processed by the slaves. Then what master node does, right? So everything done by the slave node only. Data is stored by the slaves. Data is processed by the slaves, right? Observe this diagram, right? Yes. For example, I said Hadoop follows master and slave, single master and multiple slaves, right? Yes. Single master and multiple slaves. Slave 1, slave 2, so on up to slave n, right? This is the master node. These are the slave nodes. In database, data is stored in the form of tables. In database, data is stored in the form of tables. In Hadoop, data is stored in the form of files. f1.txt files, f1.txt, right? So this, for example, each slave 1 TB of capacity, its storage capacity 1 TB, assume, right? But this f1.txt 2 TB, right? Assume the size is 2 TB. Can it fit into any of the slave? It cannot fit into any of the slaves, right? Slave 1, slave 2, if we got 100 slaves also, it cannot be stored in any of the slaves, right? So in Hadoop, data is going to be divided into parts. Two advantages you are going to see here. If you are dividing the data or file into multiple blocks, multiple parts, two advantages we see, right? And you are storing across the slaves. You are storing across the slaves. So here 2 TB file can't be stored, cannot be accommodated by any slave. But if it is divided into smaller parts, stored across multiple slaves, data is distributed across multiple slaves and data is processed by multiple slaves parallelly. Think that a 10 lakh records in this, 10 lakh records is stored in this, 10 lakh in this way, every slave storing some lakhs of records. So all the slaves are executed parallel, right? They are going to execute all the tasks parallelly. Parallel processing, you are going to see very high speed, because Hadoop has got high speed because of this parallel processing. And secondly, Hadoop, how Hadoop is able to store huge data means data is going to be split, distributed across multiple machines, multiple systems, right? And is processed parallelly, right? And here data is stored by the slaves, data is processed by the slaves. What are the master node responsibilities? So master nodes assigns tasks to the slaves. T1 task, T2 task, T3 task, executing this 10 lakh records, this 10 lakh. Okay, T1, T2, T3 task. Who is assigning? Master to slaves. And load balancing the load, right? Assigning equal tasks to each and every slave. Fault tolerance mechanism means while 3 tasks are executed by 3 slaves parallelly, suddenly if any one slave goes down, then the task of that the task of that slave T2 will be assigned to any of the other slaves. Who does this? Master. And before master assigning the task to the slave, first it will check the health status. What is the health status of each and every slave before it assigns, right? Yes.
Sir, one clarification.
Yes.
How does it know the status of the slaves? Is there any agent installed on the slave that will provide regular information to the
Yeah,
master?
see, actually, I was just giving an overview, right? Lot of things we need to discuss internally, right? Hadoop architecture, storage architecture, processing architecture. Just to know the Hadoop advantages, just I'm briefing you. Hadoop doesn't follow client server. Master slave means you will have single master, multiple slaves. But lot of things we'll be discussing. Hadoop storage architecture, Hadoop processing architecture. Again, within this master and slave, we'll have job tracker, task trackers. Job tracker assigns the task, task tracker executes the task. More precise way, right? We'll be discussing in the Hadoop architecture, right? But as of now, Hadoop follows master slave architecture, single master and multiple slaves.
Sir, is it always a single master?
So, but from Hadoop 2 version onwards, there is a high availability concept was there. There is a new feature we got, right? High availability, HA. High availability means multiple nodes we can have. Multiple, right? Even for example, if one slave goes, we have got another slave, but from Hadoop 2 version onwards, so there were some architectural changes. So I'll be discussing both, right? Both architectures, so that you will know what was previously and what was now. So how was the architectural changes? We can go with the multiple nodes, name nodes, right? Internally, again, for storage, we got a name node, data node, secondary name node. Again, for processing, job tracker, task tracker. Okay. Again, in the latest architecture, we have got a lot of components like resource manager, application manager, resource scheduler, job history server, application master, node manager, container, right? We'll be discussing what each component and how the processing is going to happen step by step. Okay. Fine. So as of now, master node responsibilities, right? Yes. First one, task assignment. Load balancing. Fault tolerance. Fault tolerance means when multiple slaves executing multiple tasks, suddenly if any slave goes down, then the task of that will need to be assigned to any of the other slave, right? And health monitoring, right? Yes. So you asked, right, one query. So heartbeat signals between the master and the slaves. If the signals are missing, then immediately it thinks that the particular slave is down. Immediately the task will be assigned to other slave. Okay, now just observe this Hadoop advantages: unlimited data storage. Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited scalability means, observe.
Like we can add new systems.
Yes, yes. You are running with a less number of slaves. Slave 3. You are running with less number of slaves, but for example, your customers are increased, your data is increased, your business increased, your branches increased, data increased by 100 times, customer increased by 1000 times. You cannot go with the same number of slaves, right? So horizontally, you will be increasing the slaves from 3 to 30. So horizontally increasing the slaves, horizontally unlimited number of slaves, horizontally unlimited number of slaves can be added. Okay, storage point of view, just observe here. You may ask, why only Hadoop can perform
Slaves are the servers, or I mean, what exactly is master slave architecture? I mean, so master is any, I mean, server. I mean, there are sub servers. I mean, how it is defined? Even
so just a group of CPUs, right? If you have got some 40 node cluster, one will behaves like the master, the other will be as the slaves. 39 will be the slaves. Means you will be configuring so master and multiple slaves. In all that master and slaves, you'll be having all the softwares be installed, but total monitoring, everything will be taken care by the master node. So okay, I'll just discuss more on this, right? Architectural part, storage and processing in that Hadoop architectural part, storage and processing. Observe here. You may ask why databases like Oracle? Why databases like Oracle? Cannot support unlimited storage. Cannot support unlimited storage. Why databases like Oracle cannot support unlimited storage? If you observe, right, even for databases, right, for example, like Oracle, in real time, we can go with multiple slaves. Databases, max limit on number of slaves. Max limit on number of slaves. Why databases like Oracle cannot support unlimited storage? So for example, Oracle, in real time, it can go with the maximum 256 nodes CPUs, right? Once beyond that, it cannot support, right? It cannot support further. Even for MySQL, right? If you talk about MySQL, you can go with 54 nodes. But MySQL Express can go with 256 nodes. SQL Server, right? SQL Server can go with 256. DB2 can go with 256. MySQL 254, MySQL Express 256 nodes, SQL Server 256, DB2 256, right? Yes. Any database, if you observe this, any of these databases, they are not supporting unlimited or huge data storage, right? But we have got some specialized databases like Teradata. They're used for data warehouse purpose. They can go with 512 nodes. Netija, they can go with 512 nodes. Teradata, Netija.
What is node? What are nodes?
Node in CPU, right? One system. 512 nodes are CPUs, right? So now currently Teradata and Netija going with 1024 slave systems, right? Slaves. Netija also, it's supporting nearly 1024 slaves for storing its data, right? but still we cannot say like Teradata or Netija, even though they are going with 1024, right? Still,
Big multinational companies, so they can also increase the nodes. So, if it is a hardware cost is there, so they can also increase and they can become a, I mean, Hadoop company, like, I mean, something
yes,
like that. Why they are not doing it? I mean, why the specialized company, like, I mean, I don't know whether Teradata is a company or not, or other these are the companies, or
so now, okay, previously if we talk about this Informatica, or if we talk about the ETL technologies, right? Previously they were using databases, right? But now when Hadoop came, right, even Hadoop is given as a plugin for this Informatica. And if you talk about the 10th version, so for supporting huge data, right? So there is no limitation on Hadoop, right? How many number of slaves you can have. So here there is no limitation. So here there is no limitation. There is no limitation on number of nodes that Hadoop can have, right? That Hadoop can have. Horizontally unlimited scalability. The main feature what we see in Hadoop, horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. So when Yahoo first time implemented Hadoop, right? When Yahoo implemented Hadoop, it went with 4,000 slaves, right? For storing its data. Currently it is going with 12,000 slaves. Yes, Facebook, right? When first time implemented Hadoop, right, it went with 8,000 slaves, right? When Facebook first time implemented Hadoop, it went with 8,000 slaves. Currently it is running with 42,000 slaves, right? 42,000 slaves, right, for storing its data. So there is no limit on the number of slaves that Hadoop can have. It can go with any number of slaves, right? Horizontally unlimited scalability. Can add or we can remove the slaves as per the requirement, right? Yes. So here if you observe, and the processing point of view also, Hadoop advantages, horizontally unlimited scalability, and one more, very high speed processing because of parallel processing. Because of what? Parallel processing. Can handle all varieties of data. So very high speed processing because of parallel processing, right? If you talk like the processing point of view, Yahoo has taken a table of 100 TB to test the speed of various databases, right, consisting of 1024 columns. Task was sorting based on 16 columns. What was the time taken by different databases, right? Oracle has taken 3.5 days to process. MySQL like 6 days. Teradata has just taken 4.5 hours. Netija has taken 3 hours, but Hadoop just 3.4 minutes, right? Latest version has taken just 1.2 minutes. That's the speed of Hadoop. So it is proven in the market. Storage point of view with unlimited, right, data storage, and processing wise very high speed, right? Yes. So if you see previously what all that ETL kinds of projects, all those are migrating towards Hadoop and Spark environment, right? Spark has got still very high speed, right? Because of this, everything storage and processing happens within the memory level, RAM level in memory, right? Yes. So, and can handle all varieties of data. So as part of this course, we'll be discussing that handling structured, unstructured, and semi-structured kind of data. Open source. Hadoop and Spark is an open source, right? No licensing required. Cost cutting, right? Commodity hardware, very high configured systems. No, Hadoop can run on any software, any systems, right? Yes. So as part of this course, right, what are the Hadoop ecosystem components and Spark components, right? What I'm going to discuss, Hadoop ecosystem components. Hadoop ecosystem components, right? So we have got some components for storage and for processing, right? For example, for storage, we have got HDFS, Hadoop Distributed File System. This is for storage, right? We'll be discussing about these commands, how we are going to pull the data from local system to Hadoop distributed systems, and similarly vice versa, right? How to export the data. And MapReduce. MapReduce is a kind of a processing component, right, which was mostly used if we talk about in 2012, 13, 14, 15, right? MapReduce has got a great boom in the market. So, but as of now, it got outdated. MapReduce, when we see Spark, right? Yes. So just I'm going to brief you about this. What is that MapReduce, mapper and reducer phases, how this processing is going to happen. So, but I'll be concentrating more on this, the techno that is mostly used, the technology, that is the components which are mostly used, right, in the industry. And even the technologies, the components, other things also I'll be just briefing you about, but more concentration will be on this. So now Apache Pig, it is also a processing component. It is also a processing component. Here we have got a language called Pig Latin. Pig Latin is the language. Use 1 second. Yes. Apache Pig for processing, we use a language called Pig Latin language. It is a simple scripting language, right? So this Pig Latin, if you write 100 lines of Java code, I can write the same task in Pig with 6 lines, right? That is what the easiness of Pig. It's a simple scripting language, and the important component of Hadoop Apache Hive, right? It is a kind of data warehouse kind of environment in Hadoop framework, where we are going to create a tables, internal, external tables, where we are going to make the data structured, create tables and querying, right? Performing querying, right? And also like some performance tuning mechanism, like partitioning, static partitioning, multi-column partitioning, dynamic partitioning, bucketing, indexing, combination of partitioning, bucketing, partitioning, indexing, combination of bucketing, indexing, combination of partitioning, bucketing, indexing, right? And working with different types of data, right? Working with the URL data, weblog data, working with XML data, working with JSON data, right? Working with UDF, UDTFs, right? Yes, user defined functions. So it's a kind of a data warehouse kind of environment. Here we use a language called HQL, which is similar to SQL, right? Yes. but only it cannot perform update and delete operations. Remaining all it can perform, right? HQL, similar to SQL only. And one more important component, right? Scoop. For important this scoop full form, right? SQL plus Hadoop. It's for SQL and Hadoop. The first two characters of SQ and last three characters, right? The first two characters and last three characters. It performs what? Scoop. It's for import and export operations. You are going to pull the data from different data sources from different databases, right? So SQL plus Hadoop, right? For import or export operations. Yes. Next, we have what? NoSQL databases. NoSQL databases also, right? So it's for random access. How to perform sequential access? But for random access, you can go for NoSQL. And one more thing, it's a schema-less behavior. Means if it's talk about SQL, record to record, same number of fields need to be maintained, right? From first record to last record. But in the case of NoSQL, record to record, different number of fields can be maintained. Okay. Record to record, number of fields can be maintained means my first record with 3 fields, second record with 5 fields, third record with 7 fields, last record with 10 fields, right? Record to record, different number of fields. But in the case of SQL, first record to last record, same number of fields need to be maintained. So as part of this course, I'm going to discuss a NoSQL database, HBase. HBase is the Hadoop database, right? HBase HBase works only for the Hadoop environment, not for other environments, right? We have got many NoSQL databases: Cassandra, MongoDB, this HBase, CouchDB, React, Peanut, Neo4j, right? So among all these, Cassandra, MongoDB, HBase are the most famous, right? Apart from this, Yarn, yet another resource negotiator, Yarn and Yarn architecture. Zookeeper, right? It's the name itself saying, right? It's controls and coordinates all the Hadoop components, right? So it's for connection establishments, other things, right? The Zookeeper will be invoked. Apart from this, I'm also going to provide you the knowledge on Flume Kafka. Going to give knowledge on Flume Kafka, right? For stream, okay, Control Z. Flume Kafka for advanced streaming and for advanced streaming and messaging also. It is a streamer and messenger, streaming and messaging. Messaging nothing but establishing the connection between different distributed applications. Streaming, what do you mean by streaming data? Data which keeps on incrementing, data which keeps on generating. Such kind of data we call it as streaming data. So we capture that by using Flume Kafka and we'll dump into Hadoop and we'll process by using many processing components, right? Okay. Apart from this one, the important component, Spark. So before I go with Spark, I'll be discussing first Scala programming language. Next, like Spark Core programming, Spark SQL programming, such like the concept of data frames, Spark SQL, and Spark streaming, micro batching. Yeah, like Spark Code, Spark SQL, and Spark Streaming. So I'll just provide you the entire knowledge of Scala before I go with Spark. So more concentration on Spark. Out of this 70 or 75 hours, right? Mostly like 45 hours I'll be spending on Spark. Remaining, like I'll be giving important components of Hadoop. Mostly I'll be concentrating like HADOOP, concentration on Scoop, NoSQL HBase, and the file system, right? And Yarn. And okay, yes. So this is what I will be discussing in brief. So it goes for 2.5 months, right? This 2.5 months course, and you'll be getting the recorded videos on daily basis. Clear notes you'll be getting. All right. Software also I'll be providing to your Google Drives. Videos also you'll be getting to Google Drives. Notes also to your Google Drives, right? Yes. Yeah. So tomorrow also you can attend the session to see more on this, right? Everyone, you can attend the session same time using the same link, right? To see more on this. Yes. Any queries you got, anyone, right?
Yeah. Hello.
Yes.
So, is there any new batch for morning session?
Morning, as of now, no.
No. Okay. Okay.
Yes.
Sir, does it include a Hadoop administration also?
So mostly my concentration will be on development side, but wherever we configuration, how to install, how to configure different components, that everything I'll be discussing.
Okay, sir. And known issues related to Hadoop let me discuss, like what are the existing issues, how to troubleshoot that we discussed.
Yes, everything I'll be discussing, right? If you are getting any errors, those things, right? How to rectify them. Yes.
Thank you.
Yeah, so tomorrow also you can attend the session same time using the same link, right? Yes. So if I'm done with your queries, right, I'll continue the session tomorrow same time. Fine. So
Thank you.
Yes. Yeah. Yeah, good evening all. So in the last session, just I was briefing you about what is big data, why Hadoop, drawbacks with current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yes. So Hadoop is meant for two things, storage and for processing. For storage, we have got HDFS. For processing, MapReduce or Spark. Yes. Current databases, they're used for OLTP, online transactional processing, Oracle, MySQL, SQL Server, right? Specialized databases like Teradata, Netezza, Vertica, DWH, OLAP, right? Yes. Hadoop is for Hadoop is for batch applications. Hadoop is for batch applications, right? Two types of applications: online applications and batch applications. User interactive applications, we say it as online applications like booking a movie ticket, making an online transaction. Batch application, user non-interactive application. Here is user is no way required. Here user is no way required. User non-interactive, batch application. User interactive application, online application. Here user gives the input. Here user is no way required. Credit card statement generation for millions of customers. Mobile statement generation for millions of customers. Drawbacks with current databases, right? Limited storage, no parallel processing. As volume increases, speed decreases, right? Excuse me. As volume increases, speed decreases. Select total amount from sales 1, total amount from sales 2, total amount from sales 3. Sales 1, sales 2, and sales 3. Total amount from sales 1, total amount from sales 2, and total amount from sales 3. 10 records, 1 lakh records, 1 crore records. Record to record as data increasing, speed decreasing, right? So the first query executes faster, the total amount of 10 records as compared with the other things, right? So volume increasing, speed decreases. Complexity increases, speed decreases. I want total amount of sales 1, average amount from sales 1, standard deviation of amount from sales 1. So query to query as the complexity increasing, speed decreasing, right? As the complexity increasing, average amount is a two-step process. Standard deviation is more internal processing required as compared with the second one, right? Yes. Okay. Database is one more biggest drawback of databases is can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Okay, Hadoop cluster, right? Group of CPUs connected in a network. Group of CPUs. Group of CPUs connected in a network, right? Group of CPUs connected in a network. Yes. So group of nodes or CPUs connected in network. Yes, there are two types of nodes. Yes, Anshu Rathod, any query? Yes. There are two types of nodes, master node and slave node. Master node responsibilities, task assignment, load balancing, fault tolerance, self monitoring, right? Hadoop follows master slave architecture. Hadoop follows master and slave architecture. Yes. Single master and multiple slaves. Slave 1, slave 2 up to slave n, right? Yes. Okay. F1.txt is divided into smaller parts. In Hadoop, data is stored in the form of files. So data is stored in the form of files, right? That's F1.txt. It is divided into smaller parts. Each part stored in one slave, each part stored in one slave, each part stored in one slave and are processed parallelly. So distributed storage and parallel processing, both we are able to see here, right? So if you come to this Hadoop advantages, so here master node assigns tasks to the slaves T1, T2, T3. Slave nodes executes the tasks. If any task is failed, then the task of that slave is assigned to any of the other slaves that we called as fault tolerance. Right? Master node responsibilities. Master nodes assigns tasks to the slaves. Slave nodes executes the tasks. If any slave goes down, then the task of it is assigned to any of the other